Okie dokie, let's get started. CORBA. An introduction to CORBA. It's nothing new, really. So, object request broker. Requesting objects, brokering out objects. From mainframe applications, and this actually comes from the CORBA website. Actually, the credits for it is at the end of the lecture. We have terminal access. Here's the mainframe application environment that we're looking at on this slide. And these slides are kind of colorful. Terminal access, these are dumb terminals. This is why CORBA is actually kind of popular. We don't really need smart, intelligent terminals. Mainframe data and applications are over here. That's really big in this picture. These guys are kind of small. So this could be a mobile device. This could be a dumb terminal. This could be a monitor and a keyboard, essentially. All connecting, and this is basically describing our client-server environment. So to client-server applications, what we're looking at is fat client. What's a fat client? Fat client is Windows. Actually, this Mac client is also fat. Not to be prejudiced against fat and skinny, but fat means there's a hard drive, and there's CD-ROM drives, there's devices, there's things in terms of the client interface that when it connects to the back-end data, what we're looking at is applications, but we're also looking at data, Oracle, DB2, Microsoft Server, Informix, Sybase, all sorts of corporate data. And so the interesting thing is, this doesn't really have any problem to it because these guys are fat, and they can have applications loaded on them that maximize the information that they're getting and can store the information locally. And it minimizes, what we want to do is minimize this arrow here as a common design goal for all the networking that's going on, because this takes speed, this takes time and energy. This does a lot of processing. If there's a big fat client, we got a lot of processor power. This can actually, look at this data and do number crunching and stuff. If this isn't fat, it can't do the number crunching. Over here, it doesn't really matter what's over here except for security purposes, and this should be shared with inside of the company. It's a kind of a design goal as well. So now what do we have? We have a multi-tier distributed application. We put something, here we have just client attaching to back-end data. Here now we put a middleware in the middle of it. We put a server in there. We have an application server. So we still have the client, but now they see the client now turned into a thin client instead of a fat client. It went on a diet. It lost some weight. It lost a processor. It lost a hard drive. It lost a bunch of space. Now we can have cell phones, mobile clients, Java clients, application clients. We also have Windows, and we have browsers, and we have the Mac, and we have all the other things we had before, which means we can take a fat client and connect it. It doesn't really matter, but now we can actually open up the door to thin clients. Thin clients are clients that don't have huge processors on them, don't have a hard drive, don't have CD-ROM drives and all that extra stuff. They're thin. And now we have the application server. The application server gives us our middle tier services, our business processes, and gives us our middle tier. And this is an example of an NT. I don't think NT is even around anymore. Unix servers. And we still have our back end. So in terms of enterprise computing, we have a variety of different computing platforms. We have a variety of different application programming environments. We have C++, C, Java, COBOL, which is still around a little bit. Not so much, but a lot of companies, older companies, banks are still using it. Basic, Perl, Smalltalk. Enterprise needs open architecture to support the heterogeneous environment. So we have a lot of different applications that are going through the middleware, that are going through the data that's at the end. In terms of the object-oriented computing environment, we're looking at Java as the language. We're looking at, in terms of making the concept consistent, we're looking at object orientation as a methodology. So everything is really being essentially written into reusable components that are accessed to the enterprise environment using objects. CORBA supplies the architecture for the distributed applications based on the open standards, works with Java, works with J2EE, works as a middleware component that makes the connection between the objects, also creates that heterogeneous reusability and put things together from many different clients, many different programming languages and environments, creates a common platform for the interconnection between those spins or those fat clients and the data that's behind it. So distributed application advantages to using this: scalability, server replication, thin, heterogeneous, different, which means they're coming from different types of clients that all can connect together, reusability, partitioned functionality, easy updating in either of either clients or servers are pretty easy to update. So competing technologies for distributed objects. And what we're looking at is the open standard-based solutions. So Java, CORBA, Enterprise Java Beans, as I just kind of went through in the last day or so, RMI. These are all different technologies that would all follow the same basic solution, except for they're used for different purposes. So CORBA is sort of a replacement for the servlets for the Java Enterprise Beans, but it works with it. So but it can also work with RMI, it can also work with JDBC, it can also work with a bunch of other competing technologies. All of the Microsoft solutions are looking at in terms of the COM, the COM+, the Visual C++. Actually, you can add .NET to this. It's a little bit outdated. Other proprietary solutions, message-oriented middleware, the MOMs, the MQ series, TP transaction processing monitors, and all sorts of other different types of middlewares. So CORBA is nothing more than another open standard that is open. What does that mean? Open interoperability, works with other technologies, provides its open, and if you want to call it, I don't know, actually, can you really call Java open source? But I guess you can. If you can, you can call CORBA open source in terms of its development. In terms of transaction processing monitors from web front ends, what we're looking at is a BEA Jolt, as in terms of that technology. It quickly extends the existing application access from the web, provides the client context maintained by the server, limited to single processes, single machines. It doesn't really provide too much scalability. Not object-oriented or truly distributed either. In terms of an example, between the two, Jolt servers consume additional processes. Jolt clients classes must be either pre-installed or downloaded as well. So you're looking at, sort of the problem with it. If you want to compare it with applets, but it's sort of the problem. Oh, now a bunch of people showing up. On the last lecture, I got people showing up. Interesting. All right. In terms of the COM and the DCOM and the COM Plus architecture, rich, well-integrated platform, only works on NT. Firewall issues associated with it, limited flexibility, scalability. The reason why I'm mentioning most of these things is as a comparison. CORBA provides a solution to all of this stuff because it provides more of a robust architecture middleware that provides the security, that provides the interoperability. So, in terms of object orientation, this is an object-oriented environment distributed as long as Windows exists. Then it's purely Windows associated. CORBA versus ad-hoc network applications. We have technical considerations. The CORBA / Enterprise Java Bean integration or implementations have integrations with object-oriented databases, or object databases, Java Beans, transaction services, security services, directory services, a bunch of different intermixing technologies. The technology itself is very similar to the Enterprise Bean environment and is used in almost the identical kind of situation. It's middleware that's loaded on, that provides the interoperability, that provides the foundation of the networking. So implemented automatically optimizes transport and marshalling strategies, just provides another API to load on to everything else to provide more features and more implementations. So it automatically provides thread models as well to the environment. In terms of business considerations, the standards are based on pretty well-known implementations, multiple competing interoperable implementations, the buy versus build trade-off, resource availability, software engineers, tools. It's just another API to learn, another application development environment to kind of consider. Then we have the OMG, the Object Management Group, and this lecture sort of reads as a sales pitch to a lot of point, but because it was created by, it was created by the object, it was created by the OMG actually. But in terms of the industry consortium, over 855 members, that's probably a pretty old statistic actually at this point, and that formed to develop the standard. But we have a distributed object standard, and CORBA actually follows that. Accepted proposals for various different specifications, communication infrastructure, object services, standard interfaces between the objects, developed the spec for the Common Object Request Broker architecture, or the CORBA, in terms of the goal. The design goal and the characteristics of the consortium to put this together to make it interoperable. No need to predetermine the programming language, the hardware platform, the operating system. It made it kind of common in terms of bringing the technologies together, the specific object request broker, or the degree of object distribution. So, in terms of the open architecture, the language neutral, independent definition language, which provided a nice benefit. Also, the location transparency that exists with the CORBA architecture. But you get this, and a lot of these pros and cons and design goal features is you could probably say the same for RMI or the same for any type of middleware. Provides common benefits. Anything that would be considered a middleware would fall into the same categories in terms of the pros and cons. In terms of the CORBA environment, another one of the goals, which may not necessarily have been the same goal for other middlewares, might be that the objects could act as client servers or both. So we do have a little bit more functionality in terms of the client strength. And the object request broker mediates the interaction between the clients and the objects themselves. So you take CORBA and you kind of think about it in terms of RMI and what I gave you during the last, or the first, I should say, interactive session. The manager itself, well, it's the CORBA. So CORBA and RMI are very similar in terms of that request. So instead of serving up a method invocation from a remote location, CORBA is pretty much serving up an object instead of, and also method invocation. It's pretty much doing the same thing in theory. It's made by somebody else, different design goals, different operability, works with Java, works with other technologies outside of Java. RMI only works with Java. So that's Java specific. CORBA works with Java Enterprise Beans. In fact, RMI will work with a Bean environment as well. All of these competing technologies are interoperable. Yeah, Internet inter-orb protocol here, specific for the OMG standard itself, and the protocols between the orbs themselves, resides on top of TCP/IP. The advantage you have with this is that it integrates with TCP/IP, sits on top of it, sort of like the way RMI does, actually. Developers don't need to learn anything, everything handles it. The protocol itself will handle it for them. Specific common format, the object references, known as an interoperable object reference, and the message exchange between the clients and the objects. So key definitions for ORB and BOA, and in terms of business objects or object requests, pretty straightforward actually. In terms of the object request broker, or the ORB, and you usually this terminology with a ton of middleware. Well, the ORB transports a client request to the remote object and returns the result implemented as either a set of client and server libraries or daemons between them, establishing the processes or the threads. and depending upon the orb implementation, may be an invocation of a method. So if you kind of look at the concept of the object request broker and you go, well, isn't RMI an object request broker? Yeah. Doesn't the enterprise Java Bean environment provide object request brokeraging services? Yeah. So they're all pretty much doing the same thing, and it's basically giving us the foundation for the structure of the client server / distributed. So we can take distributed the functionality over multiple objects, present it in a client server fashion, provide a middleware to give us the connectivity. Whether the middleware be CORBA, whether the middleware be RMI, whether the middleware be enterprise bean, container, servlet establishment, servlet technology. It's pretty much giving us the modern day foundation. So, in terms of the object adapter, the OA, and abstraction of that particular specification gives us part of the server-side library, the interface between the orb and the server processes. Gives us that missing connection between the middleware and the underlying server. Listens for client connections and requests, serves up client information from the server, passes through the orb to the client from the server. Maps the inbound request to desired target object instances. So it kind of acts, again, sort of like the RMI manager, actually, or the registry, actually, provides that lookup service for where is this object. So it's, again, doing a similar functionality. Business object adapters, the first defined by the object adapters themselves. For concrete specifications, the first defined one was for CORBA compliant orbs. So it leaves many features unsupported, requires proprietary extensions, supersedes by the portable object adapter facilitating server-side or server-side orb neutral code. Again, another piece of the puzzle for CORBA implementations that's very CORBA specific, not very open in terms of the open standard. An object reference, and this is sort of a review of the stuff we've seen already in terms of RMI and CORBA. So the object reference itself is the distributed computing equivalent to a pointer. So most people don't like the concept of pointers, but really what we're doing is we're pointing to an object that's not local. It's not memory, it's a pointer to an object. So CORBA defines interoperability object references, or IOR, to convert raw references to string form and back. So the reference to the object gets labeled with an identifier, and the identifier is sent back. So it's very similar to a pointer concept, actually, pointer to objects. So it can be stored, retrieved by the client, by the user, by the server, using other orbs, by using other methods. So it contains fixed object keys themselves. So the IOR, or the reference to the object, interoperable object reference, has keys inside. So the object is fully qualified by a name. There's a repository ID. There's a piece of information, depending upon the implementation, whatever's set, whatever's being used in terms of the reference. So user-defined data as well as instance identifiers and things. It can also contain transient information such as host and port and server, which kind of goes back to that, all of the information from TCP/IP, from the port, the host, all of the protocol information is, again, up, it's the layer up from the OSI perspective, it's the layer below it. So the layer above it, which is going to be the CORBA, or that's going to be the RMI, is going to pick up that information, it's going to use it. So it's just a pass-through in terms of setting a parameter and setting the information, making it available through the layer. Metadata also available, optional user definitions, sorts of things. So CORBA object characteristics, what makes this a little bit different from some of the other object request broker terminology, protocols, middleware applications, configurations. CORBA objects have identity to them. The server can contain multiple instances of multiple interfaces, multiple different objects. RMI, we only have one instance of one object is actually created and it's served up. We don't normally have multiple object identities or multiple instances. IOR, the object request itself, the identifier, uniquely identifies one object instance from another. And CORBA object references can be persistent as well. So some CORBA objects are transient, short-lived, long-lived, used by only one client, maybe used by many clients, persistent among many different client instances that might connect. But CORBA objects can be shared and long-lived as well. So you can there's more flexibility than in an RMI instance where you're working through an interface. You still have the interface on a CORBA environment, but you've got objects that can outlive certain applications. You have instances of objects that can actually be persistent. So, CORBA objects can share business rules, business policies, decide when to destroy an object, when to destroy itself, can outlive clients and servers, and so on. The objects themselves can be relocated. Well, so can RMI, which is loaded at a different location. So, the fixed object key on an object reference doesn't include the object's location. So the key itself is location independent, not dependent on it. CORBA objects may be relocated at admin time or run time, and might be implemented or support relocation transparently. So CORBA supports replicated objects. CORBA supports the replicated objects as well, which we don't have in RMI. We don't have any replicated objects. So what is a replicated object? It's more than one instance of the object that's doing the same thing that's located on a different server. And replicated objects might come in handy for fault tolerance and things. So imagine if you took RMI, rebuilt it, added some more features to it, gave it the ability to create more instances of more objects, put it on different servers, made it location independent, replicated it, added some security features, gave it more business logic, more rules, more parameters, more configurations, more identification for each one of the individual instances, and then you'd have CORBA. So it's just an upgraded version. Now it simplified it. There's a lot more to the technology, but it's in essence an upgraded version of the common object request broker concept. In terms of server characteristics, when we say a server, we usually mean a server process, not a server machine. One or more CORBA server processes might also be running on one particular machine. So you might have multiple. You can only have one RMI actually. If you're trying to load the registry up more than once, you're going to have issues. But on CORBA, you can have multiple different server processes running. So you can separate it out actually into different application configurations, server configurations. Each CORBA server process can contain one or more CORBA instances, object instances from one or more CORBA interfaces. So there's more multiplicity associated with the objects themselves. And the server process doesn't have to be a heavyweight one. So as an example, a Java applet can be a CORBA server. It can act as a CORBA server. Interfaces versus implementations. So we have the object and then we have the interface wrapper around it in terms of its implementation. CORBA objects are fully encapsulated, also are Java objects. Accessed through well-defined interfaces, sort of the same with an RMI interface object. It gives the available methods that are associated with that remote object. Internals are not available. Users of the object have no knowledge of the implementation. Sort of true for Java as well. Interfaces and implementations are totally separate. Yeah. For one interface, multiple implementations are possible. Yeah. Same true for Java. And one implementation may be supported by multiple interfaces. Yep. Same true for Java. So there's a lot of similarities. In terms of the location transparency, this is where one is kind of different. With the registry concept, you're registering the location of that object. With CORBA, you're not. It's not registered that same way. So the technology is a little bit different. In terms of the transparency, you can have it on different, and you can move it while the application and the server and everything's still loaded. It doesn't really matter where it's residing. So the CORBA object can be local to your process on another machine, and another process on another machine. Doesn't really matter where it's located, so you have a lot more flexibility with that. Stubs and skeletons, the same thing you get with RMI actually. Here's the client program. There's a call through a stub, same concept. And then you have the orb operation with a skeleton on the side over here for the business logic adapter on the server. Object implementation, the method that's inside of the object that's coming through the skeleton interface. And so the object request broker does nothing more than is like a resource locator, which is what the RMI registry is doing, or the registry itself. It's actually as a lookup technique to find the object on the remote system and then serve up the object. So the same concept is going on. And if you put this in a networking term, it's at the transport layer. So it's running above TCP, essentially. The location service, multi-threading, stubs and skeletons automatically generated by the IDL interfaces. And similar concept in terms of what we're looking at with an RMI environment. In terms of the dynamic invocation interface, we have the ability to go through from the client, make a call through a skeleton, and then have the object actually instantiate, have the object actually invoke and send the information back through the method call. So dynamic invocation interface, very similar in terms of its component. We just have the interface repository that it goes through if it doesn't exist, and says, okay, make a dynamic instance and serve up this object. So it'll go over and pick it and pull it back. Why use the IDL? Well, it reconciles diverse object models and programming languages, and it's very flexible. It actually works with a lot of different interfaces and different object types. Imposes the same object model on supported languages, if the language is supported. Programming language independent means that describing data types and different object interfaces from different languages, well, right now it's really just used with Java, so we don't really have that much flexibility. Purely descriptive, no procedural components, provides abstraction from the implementation, allows multiple language bindings to be defined, and then means for integrating and sharing objects from different object models and languages. How many object-oriented programming languages do we have out there? Not too many, but this provides ability for flexibility in terms of future growth, maybe? Nothing has really, well, C++ and Java, I guess you could say 2. We just had a handful. So, similar data types provides compatibility for similar object and data types. So the basic data types are similar to C, C++, Java. Actually, going back, we actually do have there's still some Smalltalk development out there. CORBA can be used with Smalltalk. It can be used with Java. It can be used with C++ in a non.NET environment, because the .NET's going to make it destroy the concept, actually. Not destroy the concept, replace the concept with another middleware technology. I'm not going to go through all of it, but these are some of the similar data types that are associated, that are supported. The float, the boolean, all those different things, the strings and stuff. Sequences, stream data, character data, strings themselves. Type defined, enumerations, constants, unions, arrays, facilities for creating your own types, also available. Preprocessor directives includes, defines. So you can see that the language interface supports probably the most popular C++ and Java. Well, most of this is C++ actually. We don't have structures and unions in Java. Operations and parameters, return type. Operations, calls, parameters, the use of parameters, the in and the out, similar to C++ function declarations. So the CORBA development process using the IDL. We have the client implementation, the object implementation over here. Not really referred to as a server, but it's more the object, because it doesn't really matter where it resides. The definition. And so we have the program structure in Java or C++ compiler that's putting this stub source together to create the client program, putting the skeleton source together for the remote interface, compiled in with the object implementation. And so we use the interface to establish the, to get the information from the particular object that we're looking at, depending upon the language that we're implementing it in. So sample ideal, here's just the interface accounting, get the outsourced balance. And the method here from this interface accounting would find the right object to invoke it. So here's an example of Java client that's using CORBA. And so if we're going to use CORBA, we install the API. We import from OMG, actually, the CORBA library, and then we start making CORBA calls. So initialize the orb, orb, make a new CORBA orb object, and then use it in a same fashion that we would program any other Java application in. So. And you do not have to actually write any CORBA programs or use CORBA with Java in this particular course. But you might find if you're working for a company that's using it, it's just very popular actually right now. Actually, I shouldn't say that. It was very popular for several years, and then it kind of went away. It was RM. It's been replaced with RMI and some other things. So the server source code looks very similar. I'm not going to go through it, but this is, if you were implementing it in Java, the thing to pay attention to is the import of the OMG CORBA library API for Java. And consequently, over here we also have the C++ implementation as well, where we're going to implement a CORBA in terms of that programming language interface as well. And so we would have associated client and associated server object for the particular language that we were implementing this in. In terms of CORBA services, the OMG has defined a set of common object services, and this is sort of the summary of this information. Frequently used components needed for building robust applications. Typically supplied by vendors, vendor-specific APIs for depending upon what application is being made. OMG defines the interfaces to the services to ensure the interoperability. So CORBA is basically giving us our common foundational middleware interoperable environment. Popular CORBA services include naming, as an example, maps logical names to server objects, references that might be hierarchical or chained, returning object references to request clients. It also has a control over events, services for events, asynchronous messaging, decouple suppliers, consumer of information, all types of different events that might occur, notification services, transaction services as well. So all of the stuff that I talked about in terms of the Java transactional support through the JTA, you can also use the corresponding CORBA information as well, CORBA API for that. In terms of notification is more robust enhancement for event service, quality of service properties, event filtering, structured events. In terms of the transaction, ensuring that the current state of the transaction of the objects is maintained, and we can track and monitor that through different things. So it manages distributed rollbacks and commits and rollbacks just the same way as the Java transaction API as we looked at yesterday. So it's a competing, aka the same type of functionality, same types of features made by somebody else, not made by Java. I should say not made by Sun. And we went through over the ACID properties yesterday as well, so I'm not going to review that. So here's our CORBA Internet Access via IIOP, the Java-enabled web browser, our applet going to the web server through HTTP protocol, going over loading applets, loading HTML pages, going to a proxy server, using the CORBA services to look at the distributed objects, the naming services, go into the relational database with the ODBC or a JDBC kind of connection. That's basically how the picture of how the CORBA sort of fits into the big picture in terms of the pieces of the puzzle, in terms of the interoperability. Excuse me, in terms of the technology. The future of CORBA 3, that's probably a little bit outdated at this point. Spec is complete. Future adoption due in November, well, that was about 5 years ago, 6 years ago. So we're probably up to, do you know what CORBA version we're actually up to? I'm not even quite sure. 6? Thought I heard someone say something. 5 or 6 or something. I could be totally wrong. I'm not a huge CORBA fan. I never really found a company. I never worked for a company that actually used it. So until you actually use it and start working with it, hard to know exactly what is it going to offer that current J2EE is not going to offer. There's a lot of overlap in terms of the functionality. So in future releases, well, probably current release / outdated information. Standards callback for firewalls. Yeah, I'm sure there's firewall support in it by now. Interoperability naming service as well. So I'm not going to go through this because this is outdated, actually. So I'm going to kind of skip through the CORBA 3 vendors. Some of those vendors aren't around anymore either. So worldwide implementations. Oracle. Yeah, Oracle does have still does support CORBA technologies. Borderline's out of business, I believe. BEA WebLogic's still around. So Cisco Interoperable Product Center. Everybody is pretty much compatible with CORBA these days. So I'm not going to go through this either. And more resources. I believe that this resource still exists. Oops. These links should still be working. Some of the university links may not be working. Free CORBA pages, information. You can find a ton of information out on the internet. Just do a web search, actually. You'll find some stuff. These books, first book may not be in print anymore. Some of these books are probably outdated. They may not actually be working. It may not necessarily be in existence. Old copies of them are probably out there, but current copies probably not. Because of so many different competing technologies, a lot of people, in the old days everyone had to know about CORBA because we didn't have any other choices. But now that other server technologies and servlets and things of that nature have really become popular, not quite as a heavy focus on CORBA implementations. So I'm going to end this, and it was just a brief overview, an introduction to CORBA. Obviously, it's not everything you need to know about CORBA. So find a good book, I think, or search the website, search the internet if you want some more information.